That tire didn't go flat because of a nail. It didn't go flat because the rubber was old. It didn't go flat because you drove too hard. It went flat because of this. A plastic cap the size of your pinky fingernail cost about 2 cents to manufacture, and that almost every car on the road is using wrong. Here's the scale of what that mistake actually costs. According to a U.S. Government Accountability Office report citing NHTSA data, more than a quarter of all passenger cars on American roads are running on at least one significantly underinflated tire. 1 in 4 cars, right now, today, on every highway you drive on. The Department of Energy estimates that roughly 2 billion gallons of fuel are wasted every single year in the United States because of underinflated tires alone. And a 5 psi drop in tire pressure can cost a driver nearly $100 annually in wasted fuel, based on U.S. Department of Energy and NHTSA estimates. That's before you count the premature tire wear, the early replacement. The blowout risk, the U.S. tire market was valued at over $55 billion in 2025. And a significant slice of that replacement demand traces back to a maintenance failure so small and so fixable, most people will never connect the two. Let's do a quick engineering teardown of your tire valve. Because most people have no idea what's actually happening at that small metal tube sticking out of their wheel, your tire valve system has 3 components. The rubber or metal stem that passes through the rim, the Schrader valve core, a spring-loaded pin inside the stem that controls airflow, and the cap on top, the actual seal that retains the pressurized air, is the valve core, a small, removable component threaded inside the valve stem. It uses the tire's internal air pressure combined with a small spring to force the valve closed against its seat, creating a reliable barrier. That core is actually engineered well. The problem isn't the core. The problem is everything that attacks it from the outside. The cap's main role is to act as a barrier, preventing external contaminants like dirt, dust, and moisture from entering the delicate valve stem mechanism. Accumulation of road grime or debris inside the stem can compromise the seating of the valve core's seals, leading to a slow and persistent leak over time. Here's the failure mechanism in plain physics. Your standard cap, the one that came on your car from the factory, is a basic plastic shell. It threads onto the valve stem with a shallow ridge on the inside. No gasket, no rubber seal, just plastic against metal threading. That contact point is not airtight under real-world conditions. Road vibration slowly loosens it. Temperature cycling, from summer heat to winter cold, causes the plastic to contract and expand, progressively degrading the thread contact. And because there is no rubber gasket, moisture, road salt, and fine grit migrate directly into the valve stem opening with every wheel rotation. Failure to reinstall valve caps exposes the valve core to potentially highly corrosive brine solutions used for ice melting on highways, automotive cleaning chemicals, and road debris. Debris stuck on the valve's sealing cup or around the spring can cause persistent air leaks and eventual flat tires. Rubber valve stems deteriorate after 3 to 5 years, developing tiny cracks at the base that allow air to seep out slowly, often losing 1 to 3 psi per week. You may not notice until the tire is visibly low or the TPMS warning light appears. Now here's the second failure mode that almost nobody talks about. Many people, trying to upgrade from basic plastic caps, switch to cheap metal ones. Chrome looking, heavy, feels premium. Many TPMS valve stems are constructed using aluminum stem. When a dissimilar metal cap, such as one made from brass or chrome, is threaded onto an aluminum stem, galvanic corrosion occurs. In the presence of road salt or moisture, this electrochemical reaction causes the cap to effectively fuse onto the stem. Attempting to remove a seized cap can result in snapping the entire valve stem, which means replacing the entire, often expensive, TPMS sensor. The U.S. tire market was valued at $55 billion in 2025. TPMS sensor replacement costs between $50 and $150 per wheel at most shops. 4 wheels, 1 wrong cap. That's up to $600 in sensor damage from a component that costs less than $1. This isn't a manufacturing accident. This is an engineering decision. The valve cap standard was set when vehicles didn't have $150 electronic sensors mounted at the valve. The standard was never updated. And the cheap replacement caps flooding the market have no obligation to tell you which metal your stem is made from. Here's the full protocol. 3 steps, under $8 total. Takes about 10 minutes per vehicle. Step 1. Identify your valve stem material. Look at the valve stem protruding from your wheel. If it's black and slightly flexible at the base, that's a standard rubber snap-in stem. Most pre-2008 vehicles and budget cars use these. If it's rigid metal, usually silver or black anodized, that's an aluminum TPMS stem. Most vehicles from 2008 onward are legally required to have TPMS and use these. This identification matters because it determines your cap material choice. Step 2, choose the correct cap. For long-term reliability, go with anodized aluminum caps that have internal rubber O-rings. They resist corrosion, seal better, and won't seize like cheap plastic ones. Avoid decorative chrome-plated plastic caps. They degrade quickly under UV exposure and can jam onto metal stems due to galvanic corrosion. For rubber stems, anodized aluminum caps with an internal O-ring are ideal. The O-ring creates a secondary seal that the factory plastic cap never had. For aluminum TPMS stems, use caps specifically rated for TPMS compatibility. These have stainless steel threads on the interior contact point, which prevents the galvanic reaction between the cap and the aluminum stem. Stainless steel threads are the only part that contact the brass or aluminum valve stem. This prevents the galvanic corrosion that fuses cheap zinc alloy caps in place. The integrated rubber O-ring creates a consistent, pliable seal that keeps out moisture, road salt, and fine dust far more effectively than the crude plastic ridge on a standard cap. A set of 4 quality anodized aluminum O-ring caps cost between $4 and $8 on Amazon. Search aluminum valve caps with O-ring TPMS safe. Brands like Milton, Slime, and Gorilla Automotive all manufacture the right version. Apply 1 small pea-sized dab of dielectric grease to the threads before installation if you're using metal caps on metal stems. Dielectric grease, available at any AutoZone or O'Reilly Auto Parts for about $3 a tube, acts as a barrier between the metals and stops the galvanic reaction before it starts. 1 tube lasts years. Step 3. Inspect and tighten or replace the valve core while you have the old caps off. Take 60 seconds to check the valve core itself. A loose core is one of the most common causes of Schrader valve leaks. Before buying a replacement, try tightening the existing core first. It takes 30 seconds. Insert a Schrader valve core tool or the slotted end of a quality cap into the center of the valve. Turn clockwise. Finger tight plus approximately 1/8 of a turn is enough. Do not over tighten as it will distort the rubber seat inside. A valve core tool costs $2 to $4 at AutoZone, Walmart, or Amazon. A 10-pack of replacement Schrader valve cores runs about $3 to $5. If the core is still leaking after tightening, then replace it. Replacement cores cost around $1 to $2 each. Getting a valve core tool and spare cores is cheaper than replacing inner tubes or tires if a Schrader valve develops a persistent leak. After reassembly, do a soapy water test. And mix a small amount of dish soap with water in a spray bottle. Spray each valve. No bubbles means no leak. If you see bubbles after tightening, the core needs replacement, the insider rule most people miss. Finger tight is not enough, and pipe wrench tight is too much. 1/8 of a turn past finger tight on the core tool. That's the exact engagement point where the rubber seat creates a complete seal without distorting. There is no shortcut around that number. Total protocol time, 10 minutes. Total material cost, $8 maximum. Results, immediate and lasting. Let's look at the full financial picture of a 0-2 engineering omission. A 5 psi drop in tire pressure results in a 2% to 4% reduction in fuel economy based on U.S. Department of Energy and NHTSA data. In a typical commuter driving 12,000 miles per year, this can cost nearly $100 annually in wasted fuel alone. According to NHTSA, properly inflated tires can save drivers as much as 11 cents per gallon on fuel. Yet only 19% of consumers properly inflate their tires, meaning 4 out of 5 consumers are losing money because of underinflated tires. Properly inflated tires can also extend average tire life by 4,700 miles. At an average tire cost of $120 to $200 per tire for a standard passenger car, 4,700 miles of additional tire life represents $30 to $50 in deferred replacement cost per tire. 4 tires. That's $120 to $200 in premature tire spending per vehicle per replacement cycle. The U.S. tire market was valued at $55 billion in 2025, with the aftermarket replacement segment, meaning tires consumers buy to replace worn-out ones, dominating that revenue. That market is driven by wear, and wear is accelerated by pressure loss. And pressure loss is accelerated by inadequate sealing at the valve cap. The 0-2 centered plastic cap is the standard fitment on virtually every new vehicle delivered in the United States. It is inexpensive to produce. It is installed at scale. And it performs exactly well enough to keep the tire from going flat overnight, while doing nothing to prevent the slow, chronic pressure loss that shortens tire life, drops fuel economy, and feeds the replacement cycle. That's not a conspiracy. That's a business model operating exactly as designed. A good enough solution that generates consistent downstream demand. The aftermarket tire industry doesn't need you to buy tires because of blowouts. It needs you to replace them on schedule. And pressure-accelerated wear guarantees that schedule. Here's what you now know that most drivers don't. The plastic cap on your valve stem is not a seal. It is a dust cover with threading. Listen, it has no rubber gasket. It creates no meaningful secondary barrier against moisture, salt, or contamination. And if you replaced it with a cheap metal cap without checking the stem material or using dielectric grease, then you may have introduced a galvanic corrosion problem that can destroy a $150 TPMS sensor the next time you try to remove it, the $8 fix. 4 anodized aluminum O-ring caps, a valve core tool, and a tube of dielectric grease addresses all 3 failure modes simultaneously. The O-ring creates the secondary seal the factory cap never had. The stainless threads prevent galvanic corrosion on TPMS stems. And the valve core tightening or replacement stops the primary leak source before it compounds into a slow drain on your fuel economy and tire life. NHTSA says properly inflated tires save as much as 11 cents per gallon and can add 700 miles to average tire life. On a vehicle driving 12,000 miles per year with average tire costs, that's hundreds of dollars per replacement cycle deferred. For the price of a coffee. The zero O2 cap that came on your car was never designed to last the life of your tire. It was designed to be adequate. And adequate, in this case, is a word that quietly costs you money every time you fill up your tank, and every time you buy a new set of tires ahead of schedule. You now know the difference between adequate and correct. And correcting it takes 10 minutes and $8. And every time you fix something that was designed to be just good enough, you take a little bit of your power back. If you want to stop paying the slow drip of a $0 oversight, then hit the like button so the algorithm shares this with someone whose tire is low again this morning and doesn't know why. Thanks for watching. I'll see you in the next one.